Hello y'all, welcome to Universe Sandbox 2 episode 11. Today we're going to be terraforming all the outer planets. Yes, that may seem a bit surprising, but yeah. Why has this stopped responding? Let me just go back. Yay, finally works. By the way, I was just looking up random functions on Wikipedia where I found whatever was there. Anyways, let's go back to yeah. Now it's just following my mouse. I don't know what's going on. Why? Why? It's just doing this. There, finally. Release! Really, stop. Let me focus on the sun. There, finally. Hated when these glitches happen. This is also an older version, I don't know why it's happening. But let's get back to topic. So, let's start with Jupiter. Now, Jupiter, as we all know, is, well, basically 98% hydrogen, so, well, not really 98%, this thing now does not simulate correctly. It's really about, what, 20 Earth mass core, yeah, that's about accurate. Let's see. Some silicon and some iron. Yeah, it's more like 93 or 94%. But yeah. The thing is, it has so much hydrogen gases that if we try to remove it, you'll just have a core there. And let's say that Jupiter just had a core. Now we've just lost one of the biggest defenders of our solar system. The Earth is going to get bombarded with comets. Bombarded, quote unquote. But yeah, mass extinctions are going to occur way more often. Yeah, if you want to look that up, you can. But yeah, that's why trying to remove all the mass out of Jupiter is a pretty dangerous thing to do. The other choice is just to keep the mass and instead try to fuse it together and do some hydrogen fusion. The thing is, if you start fusing further and further, eventually you're going to lose energy, especially in the iron stage. I mean, sure, iron is pretty far in, and you could end up with a pretty good silicon and iron mixture. It takes a lot of energy to do such stuff like this. If you want to fuse hydrogen together, for that matter, you could just turn Jupiter into a star and try to just heat up the moons around it and like that. You might as well. Some consider Jupiter to be a failed star as well. But let's say that we somehow found a way to do hydrogen fusion, quote unquote, and get this together like this. So yeah, now we have Jupiter. Now we'll have to add some water too. Let me add the water. Come on. Still don't see land? Let's see. Yeah, it's land, it's land. It's a slight difference. I don't know why Jupiter's rendered like that, but yeah. There we are. By the way, I am running 23.2 because of the problems that occur with the more recent versions. But yeah, here we are. So Jupiter may seem normal, but look at this. 42. How? Jupiter is so large that, yeah, it's getting crushed down from all sides. So things near the core are crushed a lot more. Crushed, quote unquote. But yeah, gravity, 26.6. Yeah, we'd all be pretty much dead if we landed there. But yeah, let's just say that we somehow managed to establish plant life and atmosphere and stuff like that. Once again, we'll have to use sulfur hexafluoride, but sadly 23.2 does not simulate that. And yeah, for some reason you'll have to do this because the scale height is low. As I told before, scale height's a really big problem. I've overheated the plant go set it back to 177. I think that would do. Let's see. How far is it away? Oh, it's closer to its apogee. That means it's closer. That means it's farther away from the sun. So why don't we make this 176 so it doesn't get way too warm as it gets near this, closer to the sun. I mean, it doesn't matter. It's like 0.05, but it kind of does matter here because, sadly, this thing does not simulate climate. So, yeah, because it's 23.2, only Earths are simulated climate. But yeah, look, we have Jupiter now. Yeah, it terraformed itself really quickly. 0.34 seems a reasonable albedo. What, 0.28, 0.34 is just fine at this point. The surface pressure, I can't really change that. I just can't. I mean, if I do, I'm just gonna freeze the planet. Or overheat it, because if I set it to 1 atmosphere, the greenhouse effect, according to this, just 1 atmosphere. And look at the scale height. It's 214 meters. That means that the atmospheric pressure drops to, let's see, that's 1 over E. What's 1 over E? 1 over E. Yeah, the atmospheric pressure drops to 0.37 atmospheres after 217 meters. Yeah, that's because of the 26.6 times the gravity of the Earth. So it's just holding the atmosphere in tightly. But yeah, this thing is crazy. Oh, it's warmed up. Whoa, 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 hold up. Whoa. It's not supposed to have warmed up this much. Yeah, I think we're in Houston, we got a problem. Well, assuming that this thing goes to 25 Celsius at here, and let's see, it hits 14 at 5.45, I mean, let's say it's gonna hit, let's see, I'm just gonna assume a linear relationship here. I doubt it's a linear, yeah, it's not a linear relationship, but let's say it gets close enough because you're pretty far from the sun. So yeah, 5.20, 5.35, minus 4.95, it's 0.4. And it goes from 14.6 to 14.7 to 24.7, it's 10. Which means, well, that means 10 over 0.4 means it heats up 25 degrees Celsius per astronomical unit. This thing is 5 times 0.45, it's 11.25. Well, assuming my calculations are correct, we could be seeing it drop down to 12 or 13 degrees Celsius during the winter and 24 degrees Celsius during the summer. I don't know, these simulations are not correct because once again it's 23.2, but you know what, let it 0.2. Yeah. Till then, let's go to Saturn. Saturn has a pretty decent eccentricity too. Yeah, once again, we'll have to do the same tactic we did on Jupiter. Which means, yeah, Saturn has a significant amount of water, but that, well, it's going to result in this, more like this. So Saturn will be a water world, but assuming we can establish floating platforms in the ocean without a problem, I think we're going to be fine. Now let's get to 5.2. Right now we're at 5.06. Let's just add like 200. Sadly, I'll have to do this. Oh, look, it's 130 and now it's negative 49.9. Still cold, but it'll hold. Let's see, 5.16, 17, 18, 19, and 20. Let's see what it is now. 17.7. Well, that's just a tad bit too hot. Let's just set this to 176 because it's not quite a linear relationship. I haven't really tested how it works at this point. Please comment if you know exactly how temperatures work with distance from the sun. Exactly how effective temperatures work. Because I know how they work, like, generally speaking. When it comes to effective temperature, it's like the temperature without the atmosphere, but with the albedo included in. But yeah. I'm not fully sure what the equations are for this. I just know that solar flux just decreases with the square of distance. By the time you reach here, the square of distance starts decreasing so slowly that, yeah. Well, let's see. But then once again, the larger eccentricity causes that effect to be cancelled out, basically. Yeah. Not larger eccentricity, larger difference between perigee and apogee, or perigee is the closest to the sun and apogee is the furthest. Let me actually set this to 0.3. I'll just keep Jupiter at 0.34 anyway. Okay, so it's just past the semi-major axis. Let's see the temperature, negative 50.9. Let's change this greenhouse effect to 203 degrees Celsius so it's able to warm up. 204, that's a tad bit warm. 203. Wait, it has land now? What? Thought it would have... It's supposed to be a water world. Okay, that's better. Well, what's... how far are we again? Okay. Actually, we need to warm it up a tad bit here. 202. So now we'll have to see how cold it gets furthest away from the sun. I'm assuming like 9 degrees Celsius here. Hits 21 as its closest approach. I mean, Saturn has a 0.05 eccentricity. Jupiter has similar. Saturn has 0.06, but yeah, it's pretty close. Really, stop. Stop glitching. Uranus? No, I'm not making that joke about Uranus. It's like a 3-year-old joke. Like it's a joke for 3-year-olds. I'm not. No. Also looks like Uranus is mostly water, so if we just delete the heights at this point, we can just send it somewhere else. It's gonna take a lot of work, yeah, but we can technically because it doesn't affect Uranus that much. 13.6 is at 14.5. Now its density is pretty low still because, yeah. Surface gravity 1.89. I forgot to check Saturn. What is it now? Oh god, it's 10.8. Yeah, this is a lot more manageable. 1.89 times the Earth's gravity. See Uranus' eccentricity. Has a large axial tilt that's not simulated here. Okay, eccentricity is also 0.045, close enough to 0.05. So yeah, let's see how close it is to apogee or perigee. Oh, it's just beyond it, so let's set this to just beyond the semi-major axis, so we need to keep it slightly cooler than, let's say 13 or 14. Let's put it to 14. So greenhouse effect is 225. Pretty close. 225. Yeah, we got a habitable Jupiter too. Don't mind the surface pressures, as I told, that's the air. That's the problem that's been going on for a while with 23.2. Luckily, 26 got released. Not 26. 25 or 26, I'm not sure. Those are simulations for all the planet's climate, but the problem with that is that in spite of those simulations, they're just inaccurate because it doesn't let you use sulfur hexafluoride. All these planets will let you use sulfur hexafluoride. There's no doubt about that. Let's go to Neptune. Once again, similarly, almost full of hydrogen. Not almost full of hydrogen, like almost full of water. Okay, Neptune has a much higher density. I don't know what's causing these calculations to pop up like this. I'm not sure because the density calculations on Universe Sandbox, they're not supposed to be this confusing, but yeah, I found a lot of inconsistencies. So yeah, let's just go out and come back in. It's the only way for you to see the atmosphere interface. Now Neptune, I'm pretty sure, has the lowest eccentricity of all the planets. Yep. Oh no, it doesn't? Wait, let me check the eccentricity of Neptune. Oh no, Venus is the lowest. Neptune has 0.0090, not 0.017. Okay, that's probably because of these. Well, it's gonna start alternating randomly. I've heard of these. It's kind of glitchy here too. This thing assumes an exaggerated pull of Jupiter and Saturn and Uranus. Oh, an overly exaggerated one at that. But you know what, I'm just gonna leave it there because it's still a pretty low eccentricity. So it's negative 224. We need a 239 degree, really, 239 degree greenhouse effect now. 215, 223. Once again, sulfur hexafluoride would be used, but sadly, this thing does not have sulfur hexafluoride simulation. 239. And yeah, Neptune's been terraformed. Another ocean world. Now let's go see if the dwarf planets can be terraformed. I mean, I'm pretty sure Pluto can. I just switch off John's escape, which once again you can do that here. We just switch it off. Escape due to the fact that Pluto's too small. Yeah, water vapors do escape, but it takes a long time. It doesn't take like a super short amount of time as is simulated by here. Now Pluto is actually quite a bit water. Thing still fails to simulate that, but yeah, Pluto's quite a bit water. Set our albedo to 0.3, the post greenhouse effect albedo. This is definitely wrong. This is definitely wrong. But I'll just leave it there for now because I've switched off John's escape. Go add an atmosphere. Okay, yeah, scale height's huge. Oh, I also forgot to show you Neptune's gravity. Or did I? I'm not sure, yeah. 2.36, also mostly manageable. I think you all may have gotten a glimpse of Pluto's gravity. It's wrong at this point, but I'll show you the correct one a little later. Okay, let's see. We need a greenhouse effect of... Well, Pluto has a pretty eccentric orbit, so I need to see... So yeah, it's just beyond, which means... We need to make it 30 degrees Celsius during the summer, because according to the simulation by... What was it? The Terraforming Wiki, they're saying that it'll hit negative 30 in the winter then, so which means... We need to have this right about 0, just actually a tad bit less. Say around this. We'll have to wait. It's kind of unsatisfying to see that thing didn't turn to water. According to this, the gravity is only about 3% of Earth's. That won't be correct because we're not removing any gases. Or for that matter, any mass. Pluto gravity. Come on. Of course Google does this. The one moment I need it, it always does that. That one moment. Will I really have to cut because Google takes this long to load? And, okay, 0.62, now it's frozen again. I'll have to wait for a while for this thing not to freeze. I wasn't expecting this many problems to come up. I've never seen this problem before. Now it's stuck. Forced it to close. Great. Great. Awesome. Wow. Yeah, I've got 0.62. Let me just calculate it with my phone here. 0.62 over 9.8. It's about 6.3% of Earth's gravity. Now, yeah, let's see. Pluto is cooling down. So, yeah, we'll have to wait for a bit. Wait, unless we can remove the inner planets, of course, because the inner planets we're not going to be terraforming, so they're not important to our simulation today. Okay, stop. Seriously. And I'll remove the asteroid belt. And remove all particles and dust. Now let me set this to maybe 3 years a sec. Stop! Seriously. Can I even... Oh, thank God. Okay, so it hits negative 21.8. Got a glimpse of that. And we're waiting for it to warm up. Now it's almost past 0. It's about 2. It's past 0. Oh God. Okay, if it gets past 40 degrees Celsius, then you might as well just cool it down here. Wait. Set this to 257. No, it's still too hot. It's still too hot. There. 31.2. See how Jupiter's doing now. 9 to 22. Yeah, I'd call that fine. Saturn, 7 to 23. 24. That's about fine too. They all seem to be averaging around 15.5 or 15. So Uranus is getting cold. Yeah, 3 degrees Celsius. Let's see how it gets during the summer. Summer average. Okay, that's a problem. That's a problem. It goes from 3 to 15. We need to make this at 21 during the summer. So to 211, it needs to hit 232. There. Let's see how it gets in winter now. About 8.5. And 21.1. That's fine. Go check out Neptune, 12.9, looks like that was the minimum there. (12.9 to 15.3), that would be 14.1. That's slightly cool, but I'd say that's fine still. Just using the averages, I'm not sure if it's actually the averages because the climate simulation can't run here. This thing goes to negative 32.9. It's negative 27 Fahrenheit. Cold. Let's go check out the summer. I think it's 31. Yeah. Which means it averages just below 0 degrees Celsius. We have no choice but to do that because if it averages 15 degrees Celsius, we're going to be seeing it hit 60 degrees Celsius during the summer. At least 45. Yeah, 45. That's more reasonable. But yeah, it's going to be hot during the summer then. At least now we're seeing it not that bad. It's still pretty hot. 31 degrees Celsius average. See. Yeah, 31.2. Now, planets like Eris. Eris is simply impossible to terraform. Not only because of this glitch of positive infinity, I don't know why that used to come up, but yeah. Positive infinity means it has an infinite scale height, which doesn't make any sense. That's one problem. The other is Eris has such a huge eccentricity that if you want to make it warm during the summer, then if you want to make it 15 degrees Celsius during the summer, it's freezing cold in winter. Let me just show you if I can. Actually, let's just end this and I'll just go to the Terraforming wiki and show y'all what I mean. So, Jupiter, let's go land on it. Really, I got close to it because I'm so used to getting close to playing on top. Stop, for God's sake. But yeah, it's Jupiter. Let's actually land on it now. There, that's better. Ran into the same glitch again. Let's go check out planets like Saturn. Of course, when it comes to rotational period, Jupiter is really fast, so yeah, good luck adjusting to a sleep cycle on Jupiter. Saturn's even further away, it's quite a bit darker. Stop. Stop glitching out. I'm just literally getting plagued with glitches. That's Saturn. For some reason, the atmosphere is still transparent because it just fails to simulate correctly on 22.2. You can actually change atmosphere color in the more recent versions, but not here. Uranus. Yeah, Uranus has a 90-degree tilt, 42-year summers and 42-year winters. I don't know how that'll turn out for Uranus. Yeah, it's pretty dark. Let's go check out Neptune. They say that Neptune and Pluto are like the last planet where you can actually grow stuff in sunlight because anywhere beyond that it's just too dark. For example, I told you Eris is not terraformable because of its distance from the sun and also because of its eccentricity. Even if you had a ton of sulfur hexafluoride, you'd warm Eris up, but yeah, you'd still be seeing either really cold winters or ridiculously hot summers. Same thing's true of another outer planet, Sedna. Except there, if you try to make it, what, 15 degrees Celsius during the winter or the furthest part away from the sun, what is it, apogee? Yeah, apogee. Then when it's close to the sun, it'll be over 1,000 degrees Celsius. That's a problem. But yeah, here's Neptune. Let's go check out. Where's Pluto? Come on, Pluto. Where are you? There. Yeah, we came during the cooler month. Or not a month, I don't even know what to call these. I mean, if you all want, you can create unique names for Pluto months. I mean, comment down below if you have a unique name for a Pluto month. Don't tell me Plutonian. Or Hades, for that matter. Oh yeah, it's pretty dark down here. Yep. Let's see. We're waiting for it to get warmer. Yeah, it did get somewhat brighter, but yeah, it's now ocean, so the albedos decrease. But let's just assume it averages at 0.3. I don't want to mess too much because this thing just can't simulate. As I told, carbon dioxide, sulfur hexafluoride at 23.2, at version 23.2. But yeah, here we are. All of them have been terraformed. Now I'm going to the terraforming wiki. Wait for it to exit first, because yeah. Yeah, I'm on Google Earth now. Sorry y'all for this, but I'm unable to go to Terraforming Wiki because for some reason Windows won't let me record that. Just I'd open some other app because it says open a game and it'll let you see whether you have transitioned windows or not and stuff like that. But for some reason it just kept me on the same window and kept the screen still. Why it does that, I don't know, but Windows is just full of glitches. But yeah, as I was telling before, so yeah, Sedna would be hitting, let's say that Sedna was 15 degrees Celsius when it's close to the sun. It would just be negative 197 further away from the sun. That would just basically make all the sulfur hexafluoride precipitate down, cooling it even further, making all the oxygen and nitrogen precipitate down. It's gonna have no atmosphere. Now if we had 15 degrees Celsius close to the sun, not close, farthest from the sun, then you just have over 1,000 degrees Celsius close to the sun. Even if it's 15 degrees Celsius, that's the average temperature at semi-major axis, it would be way too hot at the point close to the sun. It would still be 500 degrees Celsius. Eris is a less extreme example of this, but it's still a problem on Eris. So your only choice now is just use an artificial sun. So yeah, anyways, see y'all.